Okay, so today what I'm going to do is explain a few of the examples in Chris Odom's book on the if-else then statements. And what I want to do is just kind of copy and paste in the examples and run over them and explain them quickly so you get an idea of exactly what they actually mean. This kind of goes along obviously with reading the book, but this is just another way to kind of examine it. So in the first case, what I've done is I've uploaded or copied his first sort of major example. And what we're going to do here is you can see we have a number of if statements. And in this particular case, they're all on a single line. You'll notice there are no curly braces. You can do this as long as you only ask it to do one additional function or one additional procedure. So in this case, I have it on a single line, and if this value is true, then it's going to go ahead and print out this particular command here, x is equal to 5. If I wanted to do something else, like for example equate it to another variable, well then I have to break this up, use the curly braces, and spread it out. But we'll talk about that in a second. The other thing to go over quickly is the comparison operators. This is the most confusing one right here, where people get messed up on. They'll simply say if x is equal to 5, because that's what they do in math. But in the case of the computer world and C language, we're not equating x to 5. We're actually asking if it is 5. We're asking a true or false question, in which case you have to use the comparison operator or the double equal sign. Okay? So in this particular case, we put in x is equal to 7. Okay, the single. We've equated the variable to 7. And now we're going to ask, okay, well, is it absolutely equal to 5? Is that true or false? Okay. The exclamation point is not. So in this particular case, the answer would be false. Okay. Then in the way of the computer world, since I don't have any way for it to escape, in other words, there's no breaks or no else statements or anything else to sort of separate these if statements, it's going to do them all in sequence. It's going to go right down. Okay, it is not absolutely equal to 5. Okay, then it asks the question, well, is it not equal to 5? Well, that would be true, so it would in fact put this out. All right. Is x less than 5? Well, that would be false. Is x greater than 5? Well, it's 7. That would be true. Okay? And it would go ahead and act that one out. Is it less than or equal to 5? Well, that would be false. And in this particular case, is x greater than or equal to 5? That would be true, so it acts it out. So this one here gets called, this one here gets called, and this one here gets called. Okay, but it goes through them all. It never escapes. And then it goes into a loop. And if I change this to, say, for example, 5 and run it, we should see my output change here a fair little bit. Okay, it goes through the sequence. X is equal to 5. Okay, and then it's not. All right, so it's going to skip that one. It's not less than, it's not greater than, but it is less than or equal to 5, and it is true that it is greater than or equal to 5. So these all come out. Now, through the miracles of modern digital recording, I'm going to pause this, and you'll watch the code change. All right, well, now I've entered the code for example number 2, and of course I've called it up here in my main loop, so it's going to skip one. It's going to jump right on down to example 2. Couple things here. I have added the skiff so I can get keyboard input. And what we're doing here now is we've got to look at an if-then block. Okay, so instead of it being on a single line, I've got multiple things I need to do. I need to break it up. Okay, that means I need to use the curly braces as if it was an independent function. And if this value becomes true, if rank is equal to, it's true. Number 1, in other words, I'm not equating it, I'm comparing it. If it in fact is a 1, then the value is true, and it's going to print out these 3 lines. And then it's going to go down to the next one. If it is in fact 2, it's going to print out these 3 lines. If it is in fact 3, it's going to print out these 3 lines. Once again, I have no way of escaping. It's going to go right on down this, one right after the other, until it hits the bottom, and then it's going to loop back up because it's going to get called again in an infinite loop. Now, let's run it. And as we expect, if I put in, for example, a 2, it is not a 1, it is not a 3, it's going to do the number 2. It's going to check it, and then it's go down to the second one, it's going to check, oh, it's true, it's going to do what it needs to do, and then it is going to go down to the third one and check it. Oh, it's not true, I'm going to skip it. So if I put in a 3, for example, you can see here that it checks it. Oh, it's not true, so it skips it. And it's not true, so it skips it, and it goes into the third one. Oh, it is true, and it does this, and then it loops itself back over again. Okay? So the only real difference between this one and the first example is, in fact, we're dealing with blocks. So we have the curly braces. I'm going to pause it again right now, and let's move on. Okay, in example 3, what we've done is we've expanded the capacity or range of options available to our if statement by adding an else. Okay, so in the previous examples, it was always determining whether or not it was true. Okay, like for example in the one above, if the rank was absolutely equal to or equated to 3, well, that is true and it would run the code. In this case, we've given it a choice. Okay, we're going to do a simple one here where we're going to flip a coin using a random generator. I have put the random module in, and you can see that it's going to make a decision based essentially on just one choice, and it has 2 outcomes. It's a coin, for heaven's sakes. There's a heads and there's a tails. And in this particular case, if it chooses a 0, we've decided to assign it heads. All right, and if this is true, it puts out heads. Right? But if it's false, it jumps to the else, and it puts out tails. I don't have another if coin is equated to 1. It does tails, although I could. In this particular case, I've made a shortcut, and it just says if it's true, it's heads, jump. If not, it's tails. All right. Outcome is the same. The code is different. This is just the beginning of a large expansion. But you can see it's working just fine over here. It's in an infinite loop. It's running down, and it's flipping the coin, and it's determining whether or not it is heads or tails. All right, so I think that one's pretty straightforward. Let's move on to the next example and see how this expands out. Okay, so here you can see we have as example 4, and what we've done is we've added to it a level of complexity. We're still working with the if-else blocks. Notice there's only one if statement. Everything else is else if, or else. All right, which is actually something new. I shouldn't just jump to it. Notice in this case there was only an if and an else. Now we have ifs, else ifs, and else. Okay, what you usually do typically is you end up using the else kind of as your garbage pail. It's your last choice. If I'm doing something with sensor values or something in robotics, oftentimes I'll have the else as if like something goes awry or something funny answer that you didn't pops up. You end up using the else statement as the catch-all for everything that you did or did not anticipate. But in this particular case, we're rolling a dice. Okay, and of course there's only 6 numbers on a die, 1 through 6. And what we've done here, or what Chris has done here, is he said if the die is equated to 1, put out a 1. Okay, well, if that was true, that would happen. But it was false, so it jumps down. Is it a 2? It's a false. Jump 3, whatever. If it ends up finding that it is a 4, for example, it'll print the 4, and it exits the block. All right, it doesn't it doesn't keep going. This is an important point. It exits the block. It's ready to go back up again. Okay, and what happens if it ends up being not a 1, not a 2, not a 3, not a 4, or a 5? Well, I don't have equated to 6, but we're only rolling a 6-sided die, so we can then assume that the last one is going to be a 6. Okay, So in this particular case, I imagine if I set timers up on here, which would be fun to do, I would find that it'll make its decision that the time it requires to output the data is going to be shorter depending on which number it rolls. So if it was in fact rolling a 4, it would only go so far and it would exit the block. If it was rolling a 2, it'll go so far and exit the block. It doesn't need to go all the way down. It's figured it out. It's done with that decision tree. So let's go on to the next one, and we'll move on. This next example is remarkably handy. Okay, 5A and 5B. We'll start with 5A. In 5A, we're making a decision with basically 3 different positions. In this case, Chris has chosen a random number between 1 and 12, and we're going to determine whether or not the number is small, medium, or large. If it's less than, I think how it was in the book, if it's 4 or less, it's a small number. If it's 4, 5, or 6, it's a medium number. If it's greater than, if it's 7, 8, or 9, it's a big number. Or 7 and greater is a big number. In practice, where I use something like this a lot is, let's say, for example, you have a sensor on a robot which is on a table. And you're looking down at the table. And what you want to do is you want to avoid an object on the table as well as you want to avoid falling off the table. So that means if the sensor reads something in front of it, okay, that's probably an object and you want to avoid it. You want to turn to the left or to the right. The number in your sensor is probably getting larger because something is getting closer. But if it reaches the edge of the table, suddenly the number gets smaller, okay, because it no longer sees the surface of the table. And it has to make a decision based on something which is a very small number, okay, because it's up at some elevated height. So how would you make that decision? Okay, and this is where you have to start applying some logic, and you can do this in a couple of different ways. In this particular case, we're going to start sorting from the bottom up, okay. So if the number is less than 5, well, that's a no-brainer. And if that is true, well, the number is small, okay, and it exits the block. If it goes on to the next one, let's say that the number is 6, okay, well, the first question was false. It skips it. Else if is the number less than 9? Well, if that was true, it's going to go ahead and print this out and say the number is medium and exit the block, okay. If the number was, say, 10, well, it's going to check that, that's false, check that, that's false, and it's going to go down here into the bucket and say, wow, you know, it's not, this is not true and this is not true, so the remaining false has to be the case and the number is big, okay? And the reason why it never makes it down here, for example, if you put in a 6, is because it exits the block, and then it repeats itself. It breaks it, and it's ready to do a new data set. Okay, so you can see it's randomly generating a number between 1 and 12, and it seems to be working just great. Okay, it's sorting out the numbers, and it's exiting the block as soon as the condition is met. As soon as the condition is true, exits the block. Let's look at the next one, and we'll probably have to end this video. Okay, so in the case of 5B, you can see we're doing essentially the exact same thing. It's just we're working in the other direction. All right. If the number is greater than 8, and if that value is, if that condition is true, well, then we're going to run this little bit right here, and it's going to type out the number is big, and it's going to exit the block. If this is false, it moves on down and it checks another one. Well, you know, is it bigger than 4? Okay. If it is, it's going to say that this is true, and it's going to type in medium, all right? And then it's going to exit the block. And lastly, if neither of these are true, all right, it goes to the bucket, and it decides the number must be small, okay? Well, hopefully it's perfectly logical when you think about it. Don't get tripped up. Notice one of the differences here is we've changed the value. Originally it was because we're looking for less thans and greater thans. You know, we could actually use equals to statements, but in this case if it was less than 5 and less than 9, and here we've got it greater than 8 and greater than 4. I'm going to end this, and I'll see you soon.